Hello YouTube, I'm Mr. Canfer. So in this video I'm going to show you how to start off with the Pixhawk flight controller, and you can then get a quadcopter or a hexacopter or multi-rotor going to fly. So this stage of setting this up in your multi-rotor to get to fly. So things we want to need: a Pixhawk flight controller, a receiver, and radio. So I use this is my FR Sky radio, FS I6S radio. It's for long range radio, about 3 kilometers away, using SBB, and this is a FSIA 10B receiver with a 12 channel. This is good like a Taranis radio. Now the receiver needs to support the S-bus or CBPM, like this. This one has a S-bus. If you're gonna put a PWM output in the receiver, then you're going to need a PWM converter to CPPM or S-bus converter module. All these available cheap online, look like this, very cheap to buy. So it's combine a PWM input to PPWM output, or CPPM sometimes called. Right, to power the Pixhawk we have right now, like this. You're gonna use a power module. This supply power to the Pixhawk, and also it's a voltage monitor and management and current management on the Pixhawk. So telemetry is great. You need male-to-male servo lead to connect the receiver to your Pixhawk. If you want to do a launcher mode or autopilot mode and return to launch, something like that, you need a GPS with compass. So this one is a GPS module with a compass built in. The Pixhawk doesn't have an internal compass here inside, so you need to put the external compass. So it's likely to be such as the power leads, ESCs. So it's big deflection to this compass you want to put outside like this, because we don't have inside like that. So it's cause sometimes a problem. Right, how to put this together right now? I use software, it's called a mission planner. So you can copy a mission planner from autopilot and download latest version of the mission planner, so you can launch all these firmware inside like this. Okay, right now plug in GPS. This is a GPS module. So this is 2 cables plug in here. So it's have a 5-pin or 6-pin, and the Pixhawk it's use 6 pins like this here. And sometimes you have like APM 5-pin, and the only difference it sometimes have a little gap for wires to put inside between the ground and the receive wire. So it's not easy to jump these two wires together. So I make this jump inside. So the other lead, this is compass going to I2C, like you see, I2C port, and the GPS going to GPS port. And the receiver right now is passport plug-in. So plug into the RC in the fixed hole. In this case, the ground in the top rail and the signal is the bottom rail. So some people going to put this plug into S-bus, so it's not good. I am put inside RC plug. This is a little issue, but I see this in RC. It's good signal inside. Because S-bus for output and RC for input. And the power lead going to power port like this here. This is a power port here, as you can see right now. And okay, right now to binding the receiver, if it's IA10B to the receiver, this is receiver. You want to put a jumper and power the receiver on, so going to bind in the receiver and attach these together so you can binding it easy. So we have right now 4 ESCs. It's opto ESCs. It's a 30 AMP every ESC, so ESC is going as an order to this right now to ESC's output here 1, 2, 3, 4, and the pixel is on the vibration mount like this, so the compass inside and the geofence, it's not affected in the vibration. We have right now Wi-Fi modular, so you can connect to your phone directly. Wi-Fi modular, it's going to telemetry 2. We have a 43 megahertz air telemetry radio connecting to telemetry 1, and this is an antenna for 2.4 gigahertz Wi-Fi. This is an antenna for 43 megahertz air modular, and we have down here like this. We have a FPV 5.8 gigahertz for transmitting a signal, video signal live when you on the mission, when you're flying. And we have a mini 3.8 millimeter FPV live camera like this right now. And we have a Pixhawk. We have a LED indicator here. So if you have a red and blue indicator, so you want to wait a little bit. And if you have a pulses of yellow here, so we have a system error. And if you got a blue pulses, it's searching for GPS, looking for, and it's solid green, it's armed and ready to fly. So let's go right now to the modes. So I programmed the mode here in these switches. It's 8 mode, so if you switch these, you can go into mode you program in machine planner inside this Pixhawk. So right now we have a stabilized mode. It does not need a GPS lock and keep the craft level, and height management by pilot, and manage throttle as a factor of model tilt. And this recommended this for beginner for starting the flight using this mode. Now we have loiter mode. Loiter mode is maintain the current position, heading and height. Pilot control the position. Altitude control the same as altitude hold mode. Can arm in this mode. Separate loiter and mission planner. You need a special version color of loiter, optical flow, so you can program this in mission planner. Now, and the next mode, it's return to launch mode, RTL. It's need a GPS location stored the arming, and it's file back and maintaining heading over home, posted time, default 5 seconds. Then automatically land. This mode need a GPS lock, so you can use this map in your transmitter. And right now we have another mode here in the switches. It's a guided mode. It's allow to control the craft by clicking on the map. It's need a wireless mission planner connection. You need active map link. This model you need the file and location specified in your laptop to guide the craft, the aircraft, so it can go to unknown mission and fly to it and go back to home. And we have the switches here right now. We have a follow me mode. This mode works very similar as a guided mode. Link to the ground station. It's use a GPS position of the ground station to set position. Can use a Bluetooth or Wi-Fi or normal map link connect. So it's follow you when you're going in your bicycle, when you're going in your car. It's the craft. Read the GPS from your ground station and follow you.